Alexander, that is going to be talking about C2 by Microsoft. What can actually go wrong if SCCM ends up in the wrong hands, in the hands of the attackers? Right after this presentation, you can go into the Hacking Village premiere at the second track to get your stuff if you actually won the CTFs from the Hacking Village. So don't forget that. All right, Alexander, the stage is yours.
Hello, everybody. My name is Alexander Rodchenko, and I'm a senior security analyst at Kaspersky Lab at Security Operations Center. And before I start, I just want to make a notice about my mate, Gleb. He cannot be with us due to some visa issues. That presentation cannot be done without Gleb. Gleb also perform lots of detection logic, create lots of rules, offer lots of ideas, but he cannot be with us. It's bad, but it's fact. So let's start. Who we are, who I am. I'm a security operations center analyst, and we work with Gleb also together at the top of enterprise processes. We receive requests, process enterprise threats directly, pushing some reports, and etc. and etc. We also powered with other departments of Kaspersky, like threat intel and anti-malware researchers and etc. They power up our work just to give us the ability to work with enterprise more closely. And so that I have a thought that that's why I can told you that I really understand what is the real enterprise problems. Yes, I think. And one of the real enterprise problem is an SCCM, not SCCM itself, but the ability of attackers to use SCCM as something really bad. So go into agenda. First, I little remind you what is SCCM, what they used for in normal or malicious situation, what is the architecture of SCCM. After that, we are going the most valuable part. I try to describe almost every single technique that exists that adversary abuses SCCM. Next, it's my favorite part. I try to show you demo. I write a code, and that code fully describes and implements some interesting mechanism that can catch some adversaries in your infrastructures. And I also told you about our future plans. So, what is SCCM? SCCM is a Microsoft on-prem solution to manage Microsoft operation system in corporate environments. Yes, I know SCCM can manage Linux, mobile devices, etc., and etc., but come on. Everybody knows that SCCM managed only Microsoft hosts. It's okay, generally it's true. So it can be installed like a standalone, everything in one host with some hierarchy like primary, secondary, and it's interesting like a central administration site. The SCCM server that hosts central administration site role cannot manage any host. They can manage only some sub SCCM servers. It's interesting thought, so just note about that every time. Nobody can connect to central administration site except subordinates. Also, main roles are site database server. Site database server contains every single byte that stores in SCCM. Yes, almost every single information that you see in console, I don't know, everywhere, must be stored in SQL. It's quite obvious, it's true also. SCCM has roles like distribution point, some SMS providers, and etc. and etc. It's important, but not so important than a side database server that contains almost everything. So, what is the SCCM architecture? Generally, not architecture itself, but how the data workflows process via SCCM. As I told you before, almost everything goes to SQL site server. But you cannot access and operate the data inside SQL server in SCCM. Yes, you can, but it's prohibited. You don't do that. But how? So on some on SCCM server installed exist VMI SCCM server classes, and almost every single byte before it writes on site SQL must be processed by that VMI classes. That VMI classes are executes under server process. Everything works perfectly. Also, that configuration that SCCM offers to client exposed by some EEs or bits service to clients via distribution points. So, and also nearby the same situation on client side, there was a process called SCCM exec.exe. It's a client side SCCM process working on a client. He stores some VMI service, VMI classes, and the changing that goes from management point or goes through that process, put on VMI classes, and applies by that process to current system. And the data goes directly to VMI classes, to real life on a client, and SQL site server on a SCCM side. So, also, if you want to play with SCCM, just use great resource. It's Orange Cyberdefense Game of Active Directory Lab. It contains SCCM. It's pretty nice. Just use it. I also use my own lab, but it's also a great configuration. So, the most long part. So, you're ready, I think? Go. I try to describe that such kind of attacks using the metrics. It's not MITRE attack metrics. It's a misconfiguration manager developed attack matrix only for SCCM. It describes techniques and groups it to techniques like execute, take over, recon, and etc. Just use that matrix, because using that matrix we stand on common ground when you try to figure out what happens in SCCM. So, server-side attacks. Let's start it. The first, it's recon one technique. The adversaries, the firstly, wants to find SCCM, where SCCM is located to attack him. And they try to perform some LDAP requests. So when SCCM installed on your Active Directory, it extend Active Directory schema with a new container. It's called system management. Also, it contains lots of classes that called MS, SMS, and something else. So adversaries can read it and obtain some information, but also normal clients read that. And if you feel a power, you can, for example, perform, it's an example where some sweet information located. So if you feel a power, oh my gosh, it's an example of some adversary tools that try to find something interesting. So you can, for example, configure your Active Directory with LDAP diagnostics, but do not do that because it's heavy, tricky, and cause your Active Directory down. So, but if you feel a power to fight with that technique, you can do that. Also see on some channel bindings, but calm down, it's not an attack, it's just a recon. Also, there is other recon techniques via SMB and HTTP. As I told you before, there is some roles that offers some files to clients, it's distribution point, and some management points that offers to clients some policies. Management point do it via EEs. And also, it's interesting and notable. EEs that used in SCCM also accept several special request options like SCCM post. It's important, notable, and for example, if you want to figure out which clients goes to management point, just capture using your firewall that requests. At SMB, distribution point can distribute some files via SMB shares, that SMB shares exist and have SMS or SCCM in their names. So if you make some share access audit or detailed object level access, you can see that somebody goes to SMB server and want to get out every single file inside SCCM shares. So also you just see every single client activity too, every single normal client activity too. Yes, it's a little bit boring just because it's recon. Now I want to describe what is a HTTP detection. Also, you can monitor some suspicious SCCM post options and try to find suspicious agents that connect to your management points. Also, if some guys from, I don't know, Bitdefender are here, you can also enable EES V3C logging that also available via ETV provider. You can just connect to that ETV provider and get the same information. And on SCCM server, you can retrieve the same things without any pain and find user agents and some other information that can figure out which clients are a little bit suspicious. So, much more interesting will be the next. Also, adversary might have some valid credentials to provide an access to that system, where they can grab it. So, SCCM can be can work with pre-boot execution environment. It's a service that allows to install on just clear computer operation system. How it works? It's quite simple. Via DHCP, the computer requests the address of TFTP server where bootable media stored. After that, bootable media via TFTP downloads, loads, and after that executes the operation system installation. But that media can contain network access account. In normal situation, every single request to management point, distribution point, authenticate with the data of the user of current system. But current system doesn't exist. There is no any operation system. That's why inside media can be network access account. So adversaries can download every single file that can be downloaded via TFTP, try to extract that network access account, and they, after that, try to use that recovered passwords. So what we can do with that? We can monitor PXE deploy activity, like connection to TFTP port. Also, we can see some logs on SMS PXE logs. But it's useful only for, I think, investigations. So also you can see something in deployment services diagnostics. It's really pretty nice, but it's not important. The main reason is the network access account. And when adversary steals it, they use it. If you see that some process run under that network access account, or that NA account logs via console or via RDP, it's really suspicious. Nobody does that. Or you configured something wrong. So, but generally, it's really important things to monitor. So, also, create to credential access via some trick. As you know, in normal situation, common user can create up to 10 computers in Active Directory. So hackers create a computer with their known password. After that, ask the policy. Policy comes with encrypted network access account password. They decrypt it, use a known password, and use it in your infrastructure. But it's a fake computer. When you log on console and see what is that client that stole your network access account, you see that it's almost empty. There is no information exist, especially if you just go to some instance of SMS combined devices resources class, you see that they cannot, that never stores MAC address, but normal one stores. Some data are missing or have really weird values. So just analyzed that instances and figure out which is made by adversaries just to steal network access account password. So, going next, also, that network access account can be dumped from normal computer just because network access account exists in policy, but policy are applied to lots of computers. So how it not lays directly with plain password? It's encrypted with mesh and account key. Yep, it's quite tricky. So to decrypt in that situation that password, you must retrieve the password blob, also get and mesh and key, and decrypt it. how you can obtain the password blob just via VMI, local or remote, just going directly to files that called object data, and it's under a VMI repository, and extract the blob and decrypt using machine account key. So it seems quite tricky, but generally it's existing technique when some user, for example, administrator, try to decrypt the passwords of other account. Generally, only users that have their encrypted password can decrypt it. And so if you see when somebody, for example, user administrator, try to get some blobs, encrypted password blobs of other users, it's suspicious. Try to monitor that. It's a common advice. So, and it's working on that situation to also enable SATL, also enable detailed file sharing, monitor DPP events, implement some monitoring under the Windows VMI activity. So, and you see almost everything that can describe of stolen network access account passwords. So, going next, and much more interesting thing. As I told you before, everything stored inside SCCM site server database. Also, password stores here. On Mimikatz, there is a module that can extract the password blobs from database and decrypt it via server protected keys from current server. Yes, you must also be an administrator at that database server. Yes, definitely. But in any cases, all kind of password in SCCM can be stored. It is a SQL Server account, some other accounts. Just monitor not the activity of stolen password. Just create a list of all accounts that use in your SCCM environment and monitor, as I told you, explain with network access account, the log zone, when, from, where, monitor the process that started with that account, and etc. and etc. Just use it. So also elevate next. And it's bad, really bad. Just disable it. What is elevate 2? It's when your SCCM use client push account to force installing SCCM clients. It's a contradiction. I told you before that SCCM, or maybe not told, that SCCM is a client-server, clear client-server architecture. In that situation, SCCM server try to act as a client to connect to some client and start some installation. Just disable it. And also, if client push account didn't used, there was I forget, maybe some other really powerful account was used by default. It's bad situation. Disable that functionality totally. So, takeovers. So guys, takeovers generally is nothing new. It's just coercing. So when you try to force some SCCM servers to authenticate on some other services to achieve some privileges on SCCM services. But generally, nothing new. It's like, I don't know, petit patam or other things or tricking with EFS. It's just to force and authenticate on it's just to force SCCM services to authenticate to other services to obtain some privileges. So the example. Takeover 1, it's just using petit patam to execute the SQL request to promote to full administrator of site server some other unprivileged user. Just at all. So, and generally, all takeover attacks just to put somebody to admins, and at all. Yes, many techniques, but in most common scenario, it's pushing some user to admins. So try to find that admins. So generally, the event of adding to SCCM admin group seems fully true, just because in normal situation, as I told you before, every single act on SCCM performed by SCCM service, and yes, the data from database that some user must be admin processed via VMI, and VMI system applies it system-wide. Yep, so that event are useless, but the normal admin, the normal SMS admin class looks like that. Not normal, like that. Why? Just because to promote our fake admin, we execute only one request, but the instance of SMS admin service retrieve lots of data from a SCCM site server and show us. For example, there is a fake time, there are fake modified by, and etc. and etc. So if we monitor that the appearing of new SMS admin class and in our DMMI program do that, we can capture and find something suspicious. So, and it's the last, yes, and but most valuable. As I told you, what is SCCM? SCCM is a system that powered to execute something everywhere. And adversaries use SCCM to, for example, execute some scripts or other things to every single computer in entire of your domain. So that's why execution are really dangerous. So, how it can be done? Generally, in SCCM, lots of deployment exist. For example, forcing some computer use Microsoft license, it's deployment too. But we take care about application and script deployment. In normal situation, everything works well, but there is some things, some tools that can done that deployments without user interactions, without any single promotion, like Sharp SCCM and others. So generally, the application that contains something suspicious created and its associated deployment that describes on which computer that application was deployed created. And that situation common for scripts and application itself. Also, it's interesting situation about scripts. Microsoft have a recommendation to disable antivirus scanning of folder with downloaded scripts. Don't do that, just because they can deploy invoke mimikatz via every single computer and you didn't see anything. Almost all antivirus solutions have lots of optimizations to do not rescan every single file twice. So, generally, my demo, my program, monitors that situation, and when some deployment created, it was enriched by other classes, other info, and logs on application log. And also, it's important, just realized the whole situation. Who of you see only one single security alert from SCCM? Security alert from SCCM server. For example, suspicious deployment created, suspicious script deployment created, suspicious account created. Nobody. And generally, also the same situation in other systems. Exchange, nobody see nothing like new BCC copy added to all senders, new email workflow, suspicious workflow added to your exchange. It's a much more global problem that you can thought firstly. So, also, before I start my demo, I want to describe you the files way every single piece of information stores in SQL. The first solution is to dump OSQL database, after some time, after attack, dump again, compare, and make a decision. But it's fake way, just because that SQL database are huge. Any trigger cannot help us. Just don't use SQL. So, demo time. So, it's my lab configuration. Oh, it's almost working still. So, it's my lab. There is a host that attacks everything, Windows 11, SCCM server. So, under SCCM server, I run the SCCM info.exe. It's my program. I show you the code, show the GitHub link. So it automatically connects to current existing SCCM site server, just because it performs several hold-up requests. So it connecting and monitors of creating some new interesting classes. Yes, Windows VMI technology offers us to subscribe of new instance created events with a bunch of our interesting classes. It's common. So we can reuse that technology to improve our security. So currently we subscribe to that. Okay. Sorry. Sorry. Russian. Hop. No, everything works. Oui. So, seems my computer rebooted. Really? Okay, while it's rebooting, I just show you the heart of my code. So, the heart of my code located here. There is instance creation event. And you can create a watcher and subscribe to new events. Just don't see it that span. It means that polling every single change goes to your application with 100%. It's not a polling. It's just like intervals where the polling happens. But for example, in SQL situation, you can miss the situation when something happens, some application deployments created, but you, after perform some things, didn't see nothing just because it created and removed. So it's sad. But in that situation, you see almost everything. So, okay, great. Yeah. So, go in and just quite simple. Go into sharp SCCM and try to create deployment to all systems on GAM site with on that host, and the deployment with contain application that tries to ping Google. Create on it. So it's normal workflow, almost everything created, connected, deployment created, and yes, our program capture the deployment created event and also write them to the application log. I hope 1, 2, 3, 4. Oh, and again. So, yep, it's current time. 6:03. Yep. So what happens? We receive the deployment created event and also enrich them with information about application and clients and write down to the log information what it contains. Same command line. Also, I know that there are lots of hosts can be affected with that deployment. That's why I create an CSV that describe every single host that involved in that deployment. So seems that's how my code works. And as I told you before about SQL, so I try to do that. For example, I write a program that dump every single SQL data into JSON. I create a SQL dump on JSON, perform an attack, create the dump again, using JQ, try to find the differences, and the differences in my completely virgin small lab can just over then nearby 0.5 MB. It's huge, guys. Don't do that. And it's more interesting. For example, if we try to find where is our ping exec command, you see just only some suspicious, some unbelievable information that called application management digest that contains XML that you must parse. And you cannot use it just because it's really weird. So seems everything working well. I try to capture several classes, try to describe it. If you're a security vendor, just implement that code itself, because my code it's not a production ready, just because I'm a much more security analyst than the programmer. So that is how everything works. And seems and I seems everything is gone. Just wait a sec, I click it. Oh yeah, I forget about something. Yes, the conclusion. SCCM and other Microsoft systems are really bulky, huge, but powerful. You must monitor it. If you can monitor SCCM, it's great, just because many things happens only inside SCCM. And just follow my thought. SCCM is a system where some malware can be defined on one computer but execute on another. It really breaks the kill chain. It's make our hard to detect an attacker. So implement new tools, use new techniques to monitor such kind of activity. So, and also, yes, SCCM is powerful, and when it can abuse and where it abuse, it's really a nightmare. Just make a sense, be cautious, so protect yourself. Use my code, improve it, write some notice to me, so I open to any activity. I try to improve my code. So, and it's all questions.
Thank you very much, Alexander. If you have, so we have already a question. Just my colleague will come up with the microphone.
Hello, thank you for your presentation. First question is, as a takeaway, is there any chance to secure the network access account, first of all, or are there any other hardening activities that you could perform in order to prevent this, like segmenting your SCCM distribution and making sure that only the distribution points and site points are being presented to the network? And the second question is this also affecting the co-managed environment or those that are managed only by Intune?
A little bit quite loudly.
So the co-managed environments, if this is also affected by this kind of attacks.
Oh, so the first question, it's yes, it's definitely true. I completely forgot to told you. Yes, such kind of accounts that use an SCCM must be prohibited to logs on locally, no any RDP. For example, you can create a list of hosts when network access account can logs on for just to obtain some info push and receive some SCCM notification. Yes, you can enforce the security of such kind of account, that account, and all such kind of accounts, definitely. So, but another question about co-management resources, it's, oh, really I didn't know. So the secure co-management resources, it's, yeah, it's a problem. And I didn't know currently how you can solve it. Maybe some regulations. I don't know. Okay, sorry.